Alright, another draft physics video presentation. Comments and then we'll do a video. Same old stuff, and apparently you have to go over this and over this and over this. Just doesn't matter what I say in these videos, no one pays any fucking attention. I don't mean nobody, I'm not necessarily saying you in particular, but I just mean the audience in general is really, really stupid. And you know, you have to say things over and over and over again, apparently. That's all you can say, right? So, Pancho Larpez, who knows real name or not? I never heard of a Larpez, actually. But anyway, 28:30. So he watches a half an hour of a video. He's watched other videos, clearly commented, and somewhere he thinks he draws this conclusion. But you break up photons into bits of photons. Yeah, I already pointed this out 4,000 times. The word photon isn't too good a word. Yeah, okay, so the fact that physics called something a ton, that's a little more complicated than that. Yeah, not my fault, asshole. Anyway, and then reassemble them. Yes, it's a composite. I've already explained this. I'll explain it one more time just for you, and that's it. Well, I'll probably have to explain it many more times. As I pointed out, photons, even if you believe in your fucking wave theory crap, okay, there's this concept of how much is a fucking photon, retard. Now, you people are all too stupid to ever ask physics the simple question. Well, what the fuck is a photon? Is one of these things a photon? Is two of these things a photon? Is three of these things a photon? I mean, how many of them do you need to make a fucking ton? Is this a photon? Are you really dumb enough to think this is a photon? One little fucking stupid goddamn fucking cunt wave. This is a photon. You think that's the fucking truth, retard? So even by the conventional theory, you had to have some fucking idiotic notion in your head that, oh, well, a photon has to be more than one of these things, because if there's only one of them, you can hardly tell there's a frequency. I mean, you had to occur to you somewhere in your little fucking rotten, crappy, shitty little brain that, yeah, their theory is a little bit incomplete because it never really explains what this thing is. Alright, so, but there is an explanation. I mean, the really good physicists will tell you, oh, well, no, there's this idea that there's a quantization of the photon, and that the fact is you need maybe 6 of those little humps, okay, for a human eye to see it, and that a frog can see 3 of them. Alright, so a good physicist might explain that, yeah, that's sort of the concept. I mean, we say, you need 6 photons for a human to see it, but we don't really mean photons, like the whole photon. We mean these quantized bits, the waves. You need 6 waves before you have a photon a human can see, but the frog can do it with 4. Or 3. I've been over this. And again, it's in their theory already. It's already a big question mark sitting there glaring at you, idiot. Okay, so anyway, so the truth of photons is they have a length. They also have something called polarization. Okay, that means they have a thickness. And I've pointed out it's about 2,000 atoms worth for the average visible photon. That is at 500 nanometers. Okay, that's, an average atom is a half a nanometer. You can just kind of do the math and figure out that, yes, you could probably fit 2,000 atoms inside the polarization of the wave. That is the bigness of it. Okay, and then all you have left is how many of the little things are inside of it. Now, I've simplified all of that wavy crap and magnetic and electric field crap by just pointing out, no, they're just clumps of momentum, clumps of momentum, clumps of momentum. There. Okay, and that the clumps are spatially, okay, in different places, because when they were created by an electric current, the electric current moved through a series of atoms. So big atoms were sitting there minding their own business. They got hit with electricity, and the atoms misshaped in the process. They distorted in their shape, okay, because of the pressure. So when you push them this way, they expand that way. So the electrons expand here, expand here, expand here in sequence. So at the speed of light transmitting through the atoms, the little photons go pop, 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 pop. And that's pop, 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 pop. You know, they pop in order. So this is what's creating the polarization, is the transmission through the atoms. Yeah. So obviously it's a discontinuous process because it takes more atoms than just 6 to create the photon, or else the polarization would be really narrow. But the fact that the polarization is so big indicates the atoms have some size to them relative to the little bits, and that you know, this distance is longer than the thickness of an atom. So the atoms must have some spatial rules dictating where their electrons actually are spatially, and such. And this has to do with the fact that most metals are crystals, and it's the crystal that's going to produce the photon, and blah blah blah. So there's, you know, it even gets a little more complicated when you start talking about the thing that's creating the photon. But these are the basic rules. Okay, polarization is how much the bullets are out of alignment. As I pointed out, if the gun's moving each time you shoot it, the bullets won't be perfectly in alignment, but they're perfectly parallel to each other in their movement. Alright, get it? I mean, really, separation between the bullets, polarization. Frequency is how fast the bullets are, how much distance there is between the bullets. The bullets are all moving the same speed, c, and you have a certain number of bullets that have to hit a surface for the surface to trigger an electrical response that will say, ah, a photon happened. There. That's the simple thing. I've always argued. I haven't argued anything different. Not that complicated. And then you'll say something like, okay, but if you break up photons into bits of photons and then reassemble them, you contradict your own theory. How so, fuckhead? Yeah, there is no how so, you dumb shit. I mean, contradiction is a serious accusation, jackass. Anybody with intelligence, being called a hypocrite or a contradictor or any of that crap, that's a serious accusation. You're going to make a serious accusation, you have some fucking evidence of some kind that I've said anything contradictory in that explanation, you fuck. Oh, God, I'm just so sick of you dumbasses. So I'll just delete him for now, because maybe I'll wait till later to block the idiot. So this Magoo guy is doing his shit again after I already said, don't talk your theory on my pages, fuckhead. I'm not here to debunk every little tinfoil hat loop-de-doo. It's not my job, shit for brain. Go attention whore somewhere else. Okay. You compared photons to water molecules. So this is Jerry Hall. Some more bullshit. So another statement doesn't make any sense at all. You compare photons to water molecules. No, I don't. I try in every way to point out how it's a silly comparison, that the two fucking things are completely fucking different, that water doesn't do any of this fucking shit, you fuckhead. So again, more lies. I mean, can't you people paraphrase anything accurately? Can't you ever listen and pay any fucking attention at all? I mean, amazing course shit. In a previous video, bullshit. Alright, Yale Courses has a video called The Wave Theory of Light. Yeah, I already played 2 of this guy's. Well, I played more than that, actually. I almost did a series of videos where I did the whole fucking course, but he does so much of it as math, he doesn't draw shit, that frankly it's not very good conceptual physics. Not too many concepts involved. But anyway, I've already played this video, but I'll play it again and do the same shit all over again because you can't follow along. Are you actually Jerry Hall, what, you know, Mick Jagger's dumbass retard wife or something? I mean, how fucking stupid are you? Alright, anyway. That reminded me of what you said. The individual photons are particles put together, they act like a wave. Well, they really don't act like a wave. That's the whole fucking point. See, what you people aren't getting is critical to a wave theory. The reason why water and sound work is because the medium, okay, the thing those things are traveling through, the pieces are directly connected to each other. The atmosphere, because of atmospheric pressure that's pushing them into each other, so they can't help but keep communicating with each other because they're pushed closer to each other than they like to be. And water is just because water molecules really love each other, so they all, have little connected hearty things, and they're all like, I love you, 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 I love you. So look, that's water, okay? Water is a bunch of shit connected to a bunch of shit. So if you move one piece of the fucking bullshit, you move this piece, well, this piece moves, this piece moves, this, they all move, okay? That's what water tends to do. It spreads any motion through all of the molecules, and all of the molecules collectively move. Clearly, what I'm arguing is when you shoot a gun and shoot some bullets at a sequence, okay, there's a bullet, there's a bullet, there's a bullet. Okay, well, if I take another gun, and another gun, and another gun, and put them all in sequence, and I shoot bullets, all right, it looks like, oh, look, they're doing something, wave-like. But it's not really a wave, because none of these bullets are connected to each other. They don't give a shit about each other. If something happens to one of these bullets, the rest of the bullets don't give a fuck. So it has nothing to do with wave theory. They're not all connected to each other and saying, well, how are you doing, buddy? Are you okay? No, they can get shot off this way and shot off that way and fly this way and fly that way. They're all free fucking agents. Unlike water molecules, they're not free agents. Water molecule here can't just say, I'm leaving. You people suck. It can't go fly out on its own. It can't go anywhere. It doesn't have any liberty. Okay? Everything is connected. So water, like when it splashes, you see a big fucking drop go up in the air, okay? Not one little molecule doesn't go up in the air. Now a big clump goes up in the air, another clump over here, a clump over there. They can break off in clumps, but that's the best they can do to resist the Borg, okay, of being part of water. So, this is about ether theories, okay? The conventional loop-de-doos all believe in a little faggoty ether, and they can't get over it, some sort of fetish they have for sticky shit. See, I always hated sticky shit as a kid, so that's probably one of the reasons why your physics seems gross and disgusting to me, is because it's made out of this sticky crap. You fucking candy eaters, your sticky cotton candy crap and your other crap that you slopheads eat. That gross caramel crap over shit or some other kind of goop. You're all goop lovers. Yeah, well, so that's goop, goop theory. You have a goop theory. That's what conventional physics believes the universe is made out of. There's this eternal goop. It's all a goop we're living in. And, matter is like anti-goop, So there's little pieces of anti-goop in the fucking goop. That's how they look at things, how they see things, okay? It's not goop. I'm pointing out how we can prove it's not goop because the little bits don't give a fuck about each other. Nothing's sticking to anything, okay? The energy, the momentum of a photon can be scattered all over the frickin' place. And then you have to reassemble it. So there is no destructive interference, as I pointed out. What's happening is that a big fat photon hits the fucking slit. It gets broken. That is, pieces of it hit the fucking wall. So this area ends up being a dark area. And this end area ends up being a dark area, actually. But you have to understand the slit is long. Okay, so when you make this dark area here, well, guess what? Some of the broken pieces scatter this way, and some of them scatter this way. That is into the board, okay, from these horizontal directions, and they remake photons. So they put the light back, and guess what? They'll put it back in a way you can actually see it. You can just put your goddamn fingers together in front of your computer screen, and you'll see it. Put them close together, and you'll see it, for fuck's sake. You'll see how there's this darkness around the edge of your finger and the other finger. And then all of a sudden when you get close enough, you get some lines in the darkness. Some bright lines. That's the reconstruction. You break photons and then you remake photons. So there's a bunch of little bits flying in all these directions, and the simple math says, where do the little bits add up? Where are they in phase? If I go this way and this way, are the notches on the lines line up? Do the notches line up? And if the notches line up, that is, you have this on part, on off, on off, on off, on off, on off, on off. If the two ons add up, well, then you have a chance of having a photon there. And in the case of the double slit, you're sending these two, from these two slits, are creating on, and that makes this pattern. And then these two slits, which are much further from each other, create much longer lines. So they have a lot more little notches on their ruler. And so they can make a little spot, and then a little spot, and a little spot, and a little spot. And so the little spots are on top of the background, and they're really just all bits. So they're all being, you're putting them together, and so it's really, you're squaring the effect, because you're taking, like if you did this as a random experiment of heads and, let's say you had to match heads and tails or something, and you had 10 pennies to match. Well, if you make it 20 pennies, you're going to get twice as likely to make matches because of the volume of extra pennies you're putting in the permutation. So the fact is the more the more sources you make, you double the chance of remaking a photon in these locations where the lines are. And so that's all the two patterns are. It's one pattern superimposed on another pattern. They do add up. That's what the Fresnel or Fortenhauer math demonstrates. The math is really just saying take a number of slits, okay, they then just do this, add this to this, you can see that, right? Yeah, to this, okay, you just keep adding them up. What's the contributions? What are the possible contributions from these angles, and where do they line up with their phase? And what you find out is the outside slits are making the little bars. Okay, that's a little bar. And then the tighter I make the slits, the bigger the bars get. Okay, and they're all just stacked up on top of each other. And the places where you have the most bars, that'll be an on. And the places where there aren't bars lined up, that is the bright spot ends up being over a dark spot, you know, kind of thing. This one will be a dark spot because they don't line up. And then they'll reline up again at another location where they'll all be on again. And then they'll do it again and again. And that's the pattern, and that's why the more slits you add, the wider it gets, because the distance gets longer and longer. It's just not that complicated. So anyway, continue reading. Put together act like a wave. So they don't act like a wave. They just barely look like one, but they don't act like one. It's an important distinction. Seems like, isn't anything like. Water isn't doing anything like what photons are doing. They're nothing alike, except, yes, they create the simplest pattern in the universe. On, off. Oh, fuck. The problem is the mysterious wave function. Now, it isn't a problem. It's no such thing, frankly. But anyway, we'll continue. Again, they don't use the math. They use this other math for the multi-slit, which demonstrates. The only time they get the pattern correct in the double slit, right? The wave math doesn't do this stacking thing. The wave math doesn't have a hope of getting the right pattern. So let's understand again. The real double slit, okay? The real double slit is not this stupid thing they draw. This, two waves, in. Two waves do not create the pattern. The pattern is quite different. You could draw it like that. 4 and then 3, 3, 3. It has these breaks in it. The real double slits experiment is not going to be produced by two symmetrical waves. It's a fraud, a fake, a phony, a lie, a pile of crap. And they've known it for a long time. This is what, in 1801, okay, that's when Young drew this stupid picture. All right? Well, guess what? In the 200 years since then, we have figured out this is what the real pattern looks like. Okay, so this drawing doesn't work. It doesn't make this, and it doesn't make this. But what does make that is when you think of these as the point sources, the surfaces as the point sources. So the 2 slit is really the 4 source fucking experiment. The 4 surface experiment, as I called it. And when they do this math, guess what? The first wave goes right through the barrier. Okay, these are the 2 waves they make. Okay, that math does. This wave and then this big wave. All right, so that's what you end up with. This and this 2 asymmetrical waves can create this pattern. 2 symmetrical waves can't, and this big one is basically saying this is a little tiny frequency. The bigger the wave, the smaller the frequency is a way to understand it. So this would be a big frequency. This has a little tiny frequency. So the outside slits are creating the little bars. The inside slit is creating the envelope. That's how it works. Shit. Over it, over it, over it. The mysterious wave function. Fuck. It only works for mediums. Photons aren't a medium. The momentum is not stuck to itself or each other. Alright, you can shoot photons one by one. So again, another statement that yes, physics has said this crap. It obviously doesn't happen. There's no such thing as a single photon gun. Again, they can't even tell you what a photon is. Is a photon the 6 things we see, or is it the 3 things a frog sees? Or is it the 3 things a photomultiplier sees? So no point in talking about your 1 by 1 thing. Okay, there's no such theoretical or demonstrable single photon mechanism. Fallacy. Alright, 1 by 1 on a film. After a while, the interference pattern emerges. So again, you're saying they're going 1 by 1. They're only going 1 by 1 because you reconstructed a photon. And you say, okay, there's 1 photon reconstructed. Well, to reconstruct 1 photon, you had to shoot more than 1 photon, is the simple argument. But anyway, none of that proven by any experiments. Like I said, if they did the experiment right, I've pointed out you can do these experiments. So this isn't how they do it, right? So the fact is if they did it this way, they'd find out the truth. But they don't do any of this research. They don't look into any of these details because they're so convinced, oh yes, 200 years ago we established wave theory and we don't have to defend it or anything. So, okay, so here's your photon source. You put up a screen and you just make the screen so eventually you get something on a photographic paper, just to do it right. But I mean, a camera would work nowadays. But anyway, so what you do is you send photons, who cares how many, you make this barrier and you just make it so it's thinner and thinner, and eventually a photon will hit the photographic film. And when you have like 1 an hour average or something, you can say, wow, that's really few photons. That's really 1 photon at a time, right? Because, if you only have 12 in an hour, you know that you didn't get 2 at a time. And so you have a really good source. You get a little bit of light on your film in a spot. And you say, okay, there, I have a very low photon source. Now, when you have this very low source, now put your 2 slits in. And my argument to you would be, you're not going to get shit. You're going to get 0 photons. Okay, they're just not going to survive because their polarization is almost as big as the slits. Most of them are going to get killed. And there's no possibility of reconstruction because you'll never have 2 photons in the air at the same time to go through both slits and create your scatter. So you'll have absolutely zero chance of getting any photons. So if they did the experiment that way, they would find this out. But they don't do it that way. They put the slit in there, and then they say, how many photons can I make on the wall? Well, obviously, they have no idea how many photons they're really sending in now, because they're going based on the reconstruction. So they're already depending on, they could be sending 10 or 20 or 100. Who knows how many at a time, to be able to reconstruct them. So you have to do the experiment in the right sequence. First you have to prove something, and then you can establish that as an axiom, okay, that this is a single photon gun, and then you can make your assumptions. But you can't do it. You can't do this and assume this. You have to demonstrate this first. So a huge flaw in all of the... Hey, look, it's just this sloppy physics. I've said it from the beginning. They've just gotten so fucking sloppy, lazy. It's assumption physics. It isn't, they're not doing the Edison perspiration or the Newton perspiration thing. I mean, Newton did a ton of experiments picking at things. And they don't want to do any of that. They want to do something fun. They want to make a unicorn. All right. After a while, the interferon water molecules don't behave like waves on their own, whatever that means, but apparently photons do. I don't know how. I don't even know what that sentence could even mean. Water molecules don't behave like waves on their own. I can't for the life of me know what the fuck you're talking about, but apparently photons do. They are connected somehow. There's absolutely no evidence they're connected, so I'm just saying you can say shit like that, but it just isn't true. Alright, so what's this Magoo Puke say? I think he's worth blocking now. Leave the double slit aside for a moment. No, that was perfectly legitimate on-subject comment. Your comments will be the ones off-subject. And what you are saying is similar to what I was trying to point out in my post about antennas, which doesn't make any sense because, frankly, his post is about a particular kind of interference caused by gluey ether. But anyway, particles can form a wavefront. So this is more bullshit rhetoric. Particles can form a wavefront. No, they can't unless you shoot them out of a gun or you send them like soldiers across a field. For example, if you make a machine gun go up and down, those bullets will from a wavefront of particles. See, it's not a wave because the bullets aren't connected to each other. They don't go anywhere together. Alright, DraftScience has some very interesting points. It's a shame he's dismissed my other post because it basically confirms his theory. Well, I don't see any confirmation at all. You draw a stupid fucking picture with this fucking bullshit in it. Again, I mean, you people fall for this. Things do this all on their own. My whole point to this whole physics argument is that every fucking movement has to be defended. If you're going to defend a curved line, you have to explain why it's curving. What fucking force is being applied to it to cause it to curve. The fucking universe is really fucking dumb, you idiot. It does straight fucking lines. Straight lines everywhere in the fucking basic universe is all straight fucking lines. There's no fucking curves. If you're going to say something's curved, you have to explain why it's curved. The whole point is that the moon doesn't go in a round circle around the earth. No, it's constantly going this way, and then going this way, and then going this way, and then going this way. It's always, the molecular bits inside of it are always traveling straight lines from point A to point B, and it only gets curved because they, get forced to go in a new direction by an interaction, between force and electrons. And the interaction between a force and an electron is always a straight line of some kind, a vector. And that's all that can ever happen. It's the underlying mechanism is all straight fucking lines. And then you draw this wacky bullshit again and say, there, that has something to do with my theory. It doesn't have nothing to do with my theory. I don't believe in magical curved lines. There's no such thing. Any curve anywhere is created by putting together some straight lines. Okay, so dismissed my other because it basically confirms his theory, but I think he's missing some complementary detail. Fuck you. I don't think so. You haven't pointed out what any of those are. Antenna behavior gives a lot of important clues. I've already been over fucking antennas. They're really dumb simple. Okay, it's the antennas. All the antenna's doing is saying, send a bunch of quanta, send a bunch of quanta, send a bunch of quanta. So it's vibrating. You could think of it that way, or you can think of it, doesn't matter how you think of it. It's expanding and contracting. You could say the electrons on the surface of the antenna pop out and they pop back in. They pop out and they pop back in. When they're going back in, they can't reflect anything, right? It's impossible for them to reflect the outside world when they're getting smaller at the same speed. So nothing can reflect off them. Just as I pointed out, if I move backwards at the speed of light, I become invisible, right? You understand that? If I move backwards at the speed of light away from the camera, I'm invisible, right? That's the space between the quanta. That's all you need, okay, in a universe that has a bunch of energy moving the speed of light in straight lines. Well, if I move in one direction away from all the stuff that would reflect off of me, then nothing's going to reflect off of me. That's what creates the photon. That's what creates the electromagnetic function, because it isn't a fucking wave. It's just bits reflecting off something that's now coming out, which means it's going into the force, which means it's pushing more of the little bits even more rapidly, in the sense of sooner than they would have gotten hit, because it's moving towards them. So it collects a bunch of them, reflections all at the same time, and they all end up in a row. So two things that were oh god, go over this stuff and over this stuff. So two bits of force, let's say, are separated by this much distance. If I actually bring this surface towards them at the same speed they're moving, or even, it doesn't matter, just any half the speed would be enough to get the effect. But if I bring it towards them, so they're coming this way, I bring this plate towards them, what's going to happen? Well, what's going to happen is the frequency between them is going to be cut in half. All right, and now when they leave as reflections, when they hit and reflect, instead of being this far apart, okay, they're going to be this far apart. And they might even be this far apart, like right next to each other. All right, so that's what's going to happen when you move a force the speed of light into a force moving the speed of light. You're going to end up making things that are separated by distance, you're going to end up making them very close together. So you're going to be turning energy that is, infrared, into, X-rays or something. So that's your potential to do. And again, the inverse is true. When it's going this way, the steel plate's going this way, these things can't catch up to it. They can't hit it. They can't reflect. They can't possibly get back to the rest of the universe yet, because this thing's running away from them. I mean, it's so friggin' simple. Shit. So, now I'll just delete the thread of crap. All right. And I'll go to, look, there's just no, if you can't paraphrase me correctly, then don't bother even attempting it. Because, I'm going to find it obnoxious. And if you can't pay attention, if you're going to make these statements like I haven't already explained this shit, it's just, it's unacceptable. So anyway, we'll go back to this nice enough guy, likable, all that kind of stuff. It does way too much math, so, I wouldn't take physics at Yale. The same professor isn't there. He's actually a quantum wooey professor, and they just made him teach, basic physics. And so I don't know if that was a brilliant idea.
I dropped the bombshell end of last class telling you that all the geometric optics I taught you has to be revised. And before letting you go for lunch, I said, you got it
revised, he said. Because now they're going to turn the straight line vectors of optics into a bunch of wavy shit, right? So that's the joke here, is he taught lenses and angles and all those nice straight lines, and now he's going to have to talk about woolly waves.
Tell me why I would do that. Yes, somebody said it's the experiments, and that's what I want you to remember. That's the only way things change in physics, is experiments tell you something is wrong with your theory.
Right. Now, like I said, since 1800, like I said, you could say Young, was a great science. I mean, and did a lot of good science. But I mean, this casual, sloppy little two-slit thing, again, it was already stuff Newton knew. Newton had already done the single impediment thing. Newton had already done the opening thing. He already knew about apertures, small apertures. Newton's rings are named after Newton. So clearly every component of the double slit was already something Newton had dealt with. And Newton didn't have any explanation. I mean, he couldn't offer one. Either particle or wave. Neither one made sense. Neither one fit very well, just because they didn't know what electrons were. But in the 200 years, and then there's 100 years to Young, and then Young does essentially Newton's experiments and reopens the subject and does it in this context of, look, it's just like water. Well, it only is just like water if you ignore the fact that if you do the experiment carefully, you see there's two patterns, and that's nothing like water.
And in the end, if your theory doesn't agree with the experiment, it's over. And
well, I wish that were true, because again, I think your theory of LIGO doesn't fit. There's no theory that makes any sense. Your theory of lensing doesn't work, and this two-slit wave crap doesn't work.
Conversely, if you're a newcomer, unknown to anybody, make predictions, and they agree with the experiment, then you're a rock star. Everything.
Well, it doesn't really work that way, does it? I mean, I haven't rock starred yet, have I? No, but I've certainly pointed out how waves don't work, and I have pointed out how particles do, in spite of the fact that you emphatically say they can't do something. Even though you have no scientific reason to say they can't do it when you didn't figure out every possible arrangement of a particle theory, did you? No, you're just declaring it because you're satisfied. And you're satisfied because you're not demanding much from the evidence. You're saying as long as it looks a little bit like a rhinoceros, I don't care. I think I'll call hippopotamuses rhinoceroses.
It's based on experiment. That's the only way we change our mind. Now you might say, why do you keep doing this to us? We believe you, we write everything down, we do the problems, and then you say, oh, these guys are wrong, here's a better theory. What's going on?
Yeah, what's going on? Why don't you just admit the truth? Well, we decided in the 1900s not to be very careful, and we just said, let's just get to a conclusion because we want an answer. So instead, you didn't have a good answer, and you just said, let's just grab whatever comes along. So bent space came along, you grabbed it. Superposition comes along, you grab it. Wavicle, you grab it. Particle wave duality, you grab it. Grab. And you grabbed a bunch of crap.
People really wrong. I have to be very careful when I say people are wrong, because the news leaks to the press and the media will say physicists think they're always wrong. In fact, I've gone on record here saying you're always wrong. What I mean by that is, no matter how many laws we find, one day you will find some new experiments which are not.
So there's no point in saying some kind of mush like that. So he doesn't even say it very well. Okay, this isn't very articulate, I'd argue. I mean, being incomplete and being wrong are two different things. So you could argue that fundamentally everything Newton said was right. I mean, what he said, okay, what he actually asserted, the inverse square law, that's not going away. Some of these basic rules are not going away, okay? They're not going to be undone by any new super neutrino or something. It's not going to make any of it go away. So this is stupid to say, you can't tell the difference between the stuff quite for certain and the stuff that you don't really have. You haven't ruled out all the other possibilities yet, and that's just making those distinctions. And in this case is a perfect example, because you all think you ruled out particle theory when you never did it. You never tried particle theories. You didn't sit there and spend any time thinking about it, because if you did, you'd end up doing what I did, which is pretty simple. So it's obvious you didn't spend any time doing it, because I did it. So clearly, you can see the difference between the stuff that's well established and the stuff that you didn't even really try very hard, and you're making declarations.
Explained by these laws. That's not really bad news. That's what keeps us in business, because we want to find something that doesn't fit anything we know.
Right, and then all you're finding is woo. Higgs bosons, gravity waves that Einstein said you can't see, a bunch of bullshit lensing images that are all crap. And then all this entanglement nonsense. Terribly under evidence crapola.
For example, Newtonian mechanics, in some sense, is wrong, because it doesn't work when velocities approach the speed of light.
So again, that's horse shit. There's, the very fact that, to say that it doesn't work, well, of course it does work if you understand that there's a speed limit. So if you understand you can't go faster than the force, that is, the thing pushing something is only going a certain speed. And you can never manufacture a pusher that can ever move any faster than it. Pushers can't bang into each other and get more momentum or something. They only have a certain amount of momentum, and that's it. And so it's only possible to go as fast as the pusher. You can't go any faster than that. You can't get pushed faster than the pushers are moving. So, I'm sure Newton would have said, yes, okay, you can't spin a top faster than you can spin your fingers. You can't, things you can't do. So, again, I don't think the past was ignorant enough to think that there wasn't limits.
But it's not wrong in the sense that the predictions it made in its proper domain do not work anymore. It was supposed to work in a limited range of...
All right, so there's no evidence that it doesn't work. So that's the first flaw in this argument, is that they have some evidence that it doesn't work. That's wrong. Now, if you're saying Newton's mechanics is supposed to predict a change in radioactive decay with velocity, well, of course, Newton's rules can't be applied to that, because Newton didn't even know there was such a thing as its nuclear functions.
Experimental observations. If you push the limit, if you build accelerators that send particles at very high speeds, you may find they don't obey Newtonian mechanics. Then you get Einstein's...
Yeah, you may find. So he said you may find. Again, that's all ambiguous information, frankly. The amount of energy you're putting in is a million times more than the energy you're getting out, and so you're leaking energy all over the place somewhere. So you're losing a ton of energy. And that certainly could be responsible for any effects, defects in your experiment. Obviously, you're pushing the particles continuously, I would argue. You can't leave them on their own. You don't ever trap them truly. They never trap an electron that's moving and just have it spin forever and ever and ever in the little trap. They haven't been able to do that. Theoretically, I think someday they can do that with a light photon, but I'll never do it with an electron.
Special theory. Now, if you have a special theory like Einstein, or a new theory that overthrows the old theory, and it explains new phenomena, there is still one extra requirement. Can you guess what that might be with the new theory? One thing we demand of every new theory, yes? Very good. If you go back to the old experiments, which are explained by the old theory.
Right. Yes, it's got to be a more complete end. There's no point in having a new theory if it isn't more complete and simpler. That's really all you're saying. It's got to be more efficient at answering the questions. The questions asked are, why does this happen in the experiments? And you're just saying, what's the most efficient mechanism for answering those questions the most completely? And so obviously I'm arguing I'm done that because I've unified physics and I've answered all of the questions with the same mechanism. I don't have bent space and virtual photons and entanglement and all this other whoop-de-doo bullshit. I don't need 400 different subatomic particles to explain behaviors. So yes, I've satisfied the obligation.
Well, your new theory should continue to explain that. In fact, the new theory, when it's a good one, will tell you why for hundreds of years people fell for the old theory.
Well, it's not going to give you an answer that's going to be any good. It's going to be the same answer as why did you fall for plus and minus? Well, you fell for it because it got established and everybody went for it, even though they all knew it was wrong. So a lot of shit that's wrong is just kept, and what's being kept here is the fact that you know the two-slit experiment doesn't get created by two symmetrical waves, so you know it can't be the right answer. There has to be something else going on, because you can't make those 2 point sources account for the mechanics, the outcome. You know it, and yet you're pretending it's not true. You're 200 years after Young, you know it's not the right pattern, and yet you're going to keep drawing the wrong pattern.
And then it'll also do new stuff. If you do new stuff and doesn't fit the old stuff, that's not good. So relativity is just like that. Works for all velocities up to speed of light. But if you
yeah, it only does so because you contrived it to do so with a concept that says none of the changes happen until the last 98% of the speed of light. So you basically took all of the effects and pushed them to a location where we can't see them because we can't make anything go those speeds. So the theory is indestructible in the sense that we'll never be able to see where all the action's supposed to take place because you've pushed it all to one end of the scale. Conveniently, I would argue.
Let V over C go to 0, then you'll find you get back Newtonian mechanics. Similarly, quantum mechanics.
So again, they don't ever use Einstein's mechanics to predict satellites or any of this other crap. They don't bother because, yes, all of Einstein's calculations have to do with shit that's moving frickin' 3/4 or 99% of the speed of light, and it just doesn't mean anything at 40 or 50 or 60 or 70,000 miles an hour, which are the fastest speeds we can produce anything going. It's irrelevant.
Works for very, very tiny objects, the atomic scale, but when you apply it to big things, you will find that the world begins to look Newtonian. Similarly, the end of geometric optics came from a series of experiments, and I will tell you why we didn't realize there was something wrong with it for a while. So here's an experiment you could do. Here's a screen, and there's some light coming from here, and there's a hole, and behind the screen is another screen. So I'm not good at drawing, so you should imagine this is coming out of the blackboard, and a ray of light is coming in. It'll form a shadow. I happen to have in mind a circular hole here. It'll form a disk shaped exactly like that. And another thing.
So he's talking about a big one. So he didn't say that, but there's a big hole. All right. So as I pointed out, which is so, I mean, it's so obvious it shouldn't even have to be pointed out. The simple explanation for why there's a change from, oh look, I made a big giant hole. Okay, you make a big giant hole, you're not gonna be bothering the photon too much. So if the photon's polarization is this size, then lots of photons get through the big giant hole, and only a tiny percentage of the photons hit the edge. So obviously the amount of light you're scattering is so tiny compared to the amount that goes straight through that, yes, obviously it's going to be really hard to see this little tiny effect when it's blurred out by the fact that so much of the light just went right straight through. And then obviously if I make the hole very small, what have I changed? Well, I've changed the ratio of photons not broken to photons now being broken, because the photon's almost the same size as the hole, so it's getting killed everywhere here. No matter where it goes through, it's losing something. So when I make the hole smaller, I'm obviously completely inverting the ratio of how many photons went close to the surface. That's the thing I'm changing substantially. So where this, it's like 1 in 10,000 go near the surface, here it's 1 in 10,000 that get through the middle, and the rest of them are all affected by the surface. I mean, the obvious answer to the question, why should that matter? Well, it matters because photons have a size, and because they have a size, now they're going to hit more of the surface. They're closer to the surface. But you can just see the surface is now a higher percentage of the space of the object. The surface now dominates, where the surface is irrelevant here by volume.
But you will find that as you shrink this, make it smaller and smaller, suddenly that won't be true anymore. You will find that the light spreads out like that to bigger and bigger areas. So it's no longer forming the geometric image of this aperture.
So again, this is something they already know about light, is that it doesn't spread that way. Okay, so we already know from Newton. Again, this is Newton. Already did this, so we already know what light does 300 and whatever years ago. Okay, that if I make a hole, all right, that I'm not going to get just spread. I'm going to get spread in a particular pattern of spread. I'm going to get these humps of spread. I'm going to get these things, okay, in the spread. And that we already know that this is geometry, that this is the out of phase, okay, they're out of phase distance. This distance is the wrong distance to create two in phase lines here. But this distance will create two in phase lines. These lines will be proportional clumps or sizes of the same thing. So this will be a 90 little thingy, and this will be 100. So there'll be even numbers, you could argue, or odd numbers, so you could even understand just as even and odd. And they can only make a photon where it's even numbers. They can't make one where there's odd numbers, where the two lines are mismatched in terms of the notches on the ruler. The rulers don't line up. You could do it with rulers. You could take, like, say the point where 1 foot, okay, this would be 9 inches, you could say, and this ruler is going to be 7 inches, and they line up perfectly right on the inch mark. Well, then you'll get a photon. But here they're not going to line up. This is going to be 6.5, and this one's going to be 7.5, 7 3/4 or something. Well, that's not going to make a photon, so that's not going to work.
It's fanning out. That's not going to come from the geometrical optics. That's one experiment where something goes wrong. There's a more dramatic experiment. It really puts the nail on all kinds of ray theories. That's the experiment.
So it puts the nail on all kinds of ray theories. He never thought about them. He didn't sit there again. There's so many ways you could draw geometric rays and attempt to illustrate the pattern. But I've already done it. So yes, rays do work. You don't have to do too much work to figure out how they can work, but you can make them into phases, and you can understand that, yes, they're bullets coming at a sequence, and if I have the bullets hitting the spot at the same time, it makes a photon. If the bullets hit out of sequence, it doesn't make a photon. It works fine. And it works to think that, oh yeah, it's quite possible there's a bunch of electrons on the surface, and the electrons are what are scattering the pieces of the photon to the different locations. And so you're just breaking photons and then remaking photons. So the theory works, but he declared it can't exist. His statement is, we proved it doesn't exist. We put the nail on all kinds of ray theories. They didn't put a nail on it. Kind of a broken phrase, but I mean, Lewin says exactly the same thing. Nail in the coffin evidence. So, I hate to disappoint you, but that coffin doesn't have nails in it, and that zombie's going to come back and bite you in the ass. Because it's really pissed off that you nailed it in a coffin it didn't belong in. I'm an expression of it being pissed off. That you've gotten away with this horse shit. And called it good science. Well, it's good science for us to declare something we never even thought about. And again, they never even thought about it. The evidence is, I found it so easy. Look, the idiot, the asshole, I found it. Shit. I didn't even go to college and I found it.
So you take a partition with 2 holes in it, and you send light from here, and you put a screen behind. Are you guys with me? This is a cross section of a plate coming out of the blackboard. It's got only 2 holes in it. Or here's a better way to think about it. This is the top view of an experiment. I'm looking down at my lab from the top. That's a wall with 2 holes in it, and that's the back wall. And light.
I mean, he doesn't really even know how to describe the experiment. He hasn't thought about it that much.
Is coming from here. If I close this hole, what you will find typically, let me make them slightly bigger to make my point, you will find some light. I didn't draw it properly. Most of the brightest areas will be in front of this hole.
So now he changes his drawing to do it completely wrong.
It'll tend to be big here and kind
of. Right. I mean, so, you know, I've been over this, but this is just part of this is what propaganda looks like, okay? I mean, this is quote mining, propaganda, it's distortion. You can't even call it quote mining because you're not mining anything that's anything for fool's gold. All right, the slits are less than a millimeter, okay? This is less than, we'll just say less than 2 millimeters for the whole experiment. Okay, the whole double slit experiment is less than 2 millimeters in size. All right, so obviously, it's not going to make, you know, I fell for this for a while. It's not going to make a hump over here and a hump over here. It's 2 millimeters apart. You're not even going to see the difference between where these 2 humps are. They're only going to be, the distance of this separation does not spread. It does not get scattered, okay? So it doesn't go to other locations, you know, disappear into the void somewhere or something. This separation is something that stays consistent the whole experiment. It goes straight up. So there's only going to be a 2 millimeter difference in where these 2 humps end up. 2 millimeters of difference. And at 5 meters away, you know, the enlargement, you're never going to see 2 millimeters. 2 millimeters is going to be completely invisible. The 2 would end up looking like they're right on top of each other if you block one and then block the other. All right, that's if the stupid hump theory was right anyway. Obviously, it's not. So I mean, it's, you know, just wrong. Obviously wrong.
They'll fall off. Now if you block the other one and you shine light here, you get something like that.
I mean, it's just so obviously wrong, right? And they all do it. I mean, Feynman did it. I mean, you know, you can trap so many of them in doing this simply stupid thing, you know, and it's just wrong. That's how little thought they've given it to. That's how little they've actually done this mechanics. They were just told the story, and now they're just retelling it like a Three Bear story. And it's like now and then they leave out that Papa Bear left his hat on the hat rack, or they leave out, you know, little details, and the story gets a little bit, you know, lazy and sloppy, and you know. But that's all this is. Just evidence of just, you know, telling an old fable. And they just tell it wrong and wrong and wrong and wrong, and they just pass it on as this fable we tell, and that's all it is. It's a fable of physics. It's not a reality of physics.
It's like 2 windows in the room. You got one window, you get some sunlight, you get another one, you get another sunlight. Now the question is, if you open both of them,
right, and they're 1 millimeter up. 1 millimeter, the frames were 1 millimeter different from each other, so it's 2 windows in front of each other, essentially 1 millimeter difference. Guess what? Yeah, you're not going to get 2 humps of light.
our expectation is that there is some energy coming here, some energy coming here, and if you open both, you should get the sum of the 2 energies, which I'm assuming that.
Yeah, well, that doesn't, see, even that doesn't make any sense, right? I mean, the sum of the 2, obviously they're both have an absence in the middle because you separated them so much that you create a dent in the middle. Now, obviously, if you put them a little closer to each other, you could have, you know, I mean, if he drew it even a little less worse, right, then he could at least have them overlap on their, closer to a peak. So you could get, well, you're still going to be stuck with this little negative here, but the idea would be at least then you could say, okay, we expect it to be this additive thing. But this additive thing would say that you're adding this. So this portion would go up here. So this cross section would be added here. So this would be adding them. Okay, so that works out. Okay. Never mind that part.
This is the sum of these two graphs plotted here. By the way, do you know how I'm plotting this? I hope you understand that this graph really means that distance is proportional to how bright this point is. See, normally I'm used to drawing graphs like this as a function of distance, but I've turned it around so that that is the graph of the brightness at different points.
So he'll probably mark that now. He'll say, see, where the two cross, those two have to be multiplied up. So these are on top of each other here. This part plus this part. So that's why the center gets bright. So that part's okay. But again, the basic idea that these two waves are not on top of each other in the first place is just stupid. Of course, they're right on top of each other.
On the screen.
These two bent lines.
That's what you expect. You open two windows, you get the light equal to the sum of the two. For example, if you're feeling warm, it'll be warmer in this region because you're getting light from two sources. But this experiment also gives you different results under certain conditions. I'll tell you what the conditions are. What you find then, with one slit open, it looks like that. The other slit open, it looks like that. But with both open, it looks like this.
All right.
That's called
So we've got the same squiggly bullshit, right? When we know, I mean, you know, they've known for a long time now, at least 30 or 40 years that it's been a hard fact. Certainly since the point of lasers, that the real pattern, you know, is let's put 4 of these in here and diminishing in size, so like 5, and then we have the dark spot, and then we have 3 over here, let's say, and 3 over here. Okay, this is the real pattern. And the only way you get rid of this with 2 slits is to have either, well, you could do it with multi-slits, but the only real way to get rid of it is to have either a single impediment in the middle that is near 0, okay, really small, you know, and then 2 slits, or you have a regular size impediment and you have 2 very tiny slits. But that's the only way you can make this go away. And it doesn't really go away, it just moves this way, okay? So it moves off the screen that you see, but it's always there in the 2 slit. And so obviously this doesn't say that. So this is more of just tell the story in such a sloppy and simplistic way that you just obfuscate a very important detail and just make it not have to exist, not have to be explained. Waves don't do that, is what Feynman would say. Even though Feynman drew the same stupid squiggly line, you know. But yeah, that's not a wave function, okay? You can't make 2 waves make the right pattern.
Interference. Main point to notice is there are some places, like right here, where you get less light with 1 more slit open.
Okay, so that's the assertion. Now this is true for water in the sense that water is real adding and subtracting. Water really does do destructive interference. It really does wipe energy out, balance it. So it really does destructive interference. But light doesn't, okay? So all you're doing is breaking and remaking photons. There is no breaking a photon. So this whole argument is that, you know, that it's not an additive pattern. So my argument is that what clearly happens is the 2 inside slits create this pattern. All right, you see that? Yeah, you can see it enough. All right, and the 2 outside slits add this on top of it. So they're both being projected. All right. And the truth is that this can't exist. Okay, the little bar-y stuff can't be seen without this contribution. So this one you won't see, and this one you won't see, because there's no contribution being made here. So what I'm arguing is there's little quanta, so we'll say this many of them, and it's just not enough to put a photon back together. So this thing is sending this, and it's not until the other group shows up that I can actually make a photon out of it. So this little bar needs this bar, and vice versa. They need each other to make enough amplitude, enough volume of little bits to have a realistic chance to remake a photon. So they remake photons where both the signals, that is the signal from here, the signal from here, the signal from these two interior ones, which goes all the way across here, all right, fills this entire thing. These two lines are in phase all the way across here. Okay, so just understand. And then these contributions hit here, and they end up in the same phase as these two contributions. So these contributions have the same phase as these two contributions. They hit the same spot, and then you get your little blob. But this underlying pattern is still there, and that can be demonstrated. So what they're arguing is that when you close one of these slits, you're obviously killing this and part of that, and that somehow when this composite pattern shows up, that these darks here, that this ends up dark. This is what they're saying. They're saying this place in between is dark, 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 and it really isn't. So if you look at the way it's done, you'll see that no, the dots end up blending into each other. So I already showed this, but I'll show it again. So this is the experiment where they actually do that. They block one slit at a time, essentially. And you can see how the bars, or circles in this case, end up blending right into each other. So there is no hard dark between, there's no hard separation. The darkest dark is not between any of those bars, because the underlying pattern is there. Now I could also do it with the Veritasium single photon at a time experiment, because at the time I thought it was just noise. Half his signal was noise. No, half the signal was actually the envelope. So I didn't realize it wasn't noise, because he wasn't doing, it wasn't refined enough for him to get the two humps. The extra bars. So the signal had all this, what I considered to be 50% noise in it. Well, the 50% noise was actually the envelope, and then he got the bars on top of it. So it's kind of an irony that that experiment is also evidence of this fact. And so to be able to, if you did the experiment, so you saw actual bars between, we actually see black between the small bars, the little circles in this case. If you actually see black between them, then if you do the same experiment, I would predict you won't be able to see the single slit contribution. It will be too weak to be perceived, and then that'll demonstrate it. Now you can also see it by just doing your finger trick in front of your computer screen in terms of the brightness. It's also in another older video that I'm going to play eventually, that just explains why the edges. So you sort of have to understand. Do this over and over again. But anyway, when there's a slit, you kind of understand that the edge of the slit is breaking a lot of photons, so it is already darker here, okay, than technically it is here, in a sense, because the photons are being destroyed here, where there's still some refracting in this direction, So in a way, this is the darkest place you can get, is going to be right next to this slit, because no photon is going to be able to survive going on that edge that isn't a photon you're going to see more towards that way. And if it's broken, then of course you're not going to see it, so it's dark. So it creates a there's already, by the slit itself, it's already creating a kind of curve to the light, because the edges are where there's going to be a lot of broken photons. There's more broken ones at the edges, so the edges are always going to create a darkness. So that's part of the reason why there can be a dark. We'll go into it. You just understand the basic theory is that the edges are going to be dark, because you're going to have really no chance of getting photons. Very few photons are going to run right along that edge without being destroyed, damaged.
Okay. And more light with only one open, less light with two open. In fact, you can arrange it so this is really zero. I mean, it can come all the way down here.
And right, but you can't do it, you can't arrange it to be zero and then still argue that when you block one of the slits, you're going to see the other slit's pattern. It'll be below your perception if you make that zero. So any pattern you see that's really defined, well defined, if you actually were able to block one of the slits, you'd notice that the amount of light going through the slit is really, really small. And it's so small that without the extra contribution, you wouldn't see it.
In other words, that's the point on the screen, which used to be bright with one slit open. I open the second one, that point becomes dark.
So it really doesn't.
I mean, if you're warm there and you tell...
It just becomes less light. So you can see it in the patterns look awful gray sometimes, and the division between light and dark is not a hard contrast like a really black line and then a really white line. It's just lighter gray and darker gray and lighter gray and darker gray. So it doesn't do what he's implying. It's just the fact that you can see the difference between 50% light and 100% light. It doesn't mean that the 50% is zero.
Somebody, hey, this is good, open another window, suddenly you get nothing. That happens. So when did people realize this is what happens? And why did people fall for the other graph that looks like this before? The answer is this.
So this will be crazy, right? Because we know Newton didn't fall for the other graph, right? He already knew the single slit makes a pattern. So nobody fell for that. You made it up. Like, you can't say that Newton fell for it because he didn't. And even Young, I don't know what Young thought, but I don't know if Young would have drawn that picture. So I don't think Young was that stupid.
In order to see this phenomenon, in which instead of being a shadow like this, you get a huge spread. Or instead of being simply the sum of these two featureless graphs, it starts oscillating. A certain condition has to be satisfied.
Right, so they never proved that it wasn't just the sum of those two, because the sum of those two will create the pattern. It'll look right.
Right. The condition is the following. This light, if it has a wavelength lambda, the lambda, if it is much, much smaller than any distance in the problem, then you get geometrical optics.
So the number of wavelengths that'll fit inside the distance. So if your distance is a millimeter, which is a little big, but the slit opening is a millimeter, it means 10,000 photons, 10,000 wavelengths at 500 nanometers would fit inside. So 1 millimeter is, let's just say a rough number, 10,000 wavelengths can fit inside that length. So the distance is 10,000 wavelengths difference between this surface and this surface. So you can understand when you draw these lines, you can make an awful lot of little, you have a lot of ruler to work with. A lot of notches on the ruler, potentially.
So in this example, if the slit is 1,000 times the wavelength of light, then the shadow in fact will be geometrical. But as you make the slit smaller and smaller till it becomes comparable to the wavelength, then you'll find it begins to fan out.
Okay, so he said comparable to the wavelength. It's never that small. So The slit experiments don't go that small. You don't have to go that small. I mean, it really is. I mean, there's 1,000,000 nanometers in a millimeter. No, 1,000,000. Okay, so it's a 0.00, I mean, a 0.0 some number millimeter slit. You can't get any smaller than that. That's not 1/1,000,000th of a nanometer. I mean, a millimeter.
Out. Similarly here, if this distance between the two slits, d, is much bigger than the wavelength, and each slit is much bigger than the wavelength, then you will find that you don't see any of this interference effects. Because what happens...
Well, that's just wrong. So, I don't know what to say about it, but it's obviously just wrong. Because obviously the bigger you make the slit, the more you see pattern, the more little lines you see. And so he's got... somewhere they've broken this concept of the difference between a millimeter and a nanometer, because it just doesn't make any sense. I mean, look, a millimeter is 1,000,000 nanometers. So if I have a 500 nanometer wavelength, I'm only taking, it's just 500's a lot, but I mean 500 doesn't reduce the million to nothing. It reduces it to in the hundreds of thousands, tens of thousands. So, like I said, it just doesn't make any sense. The slits are always bigger than the wavelength of the light.
Interference effects are always there, but they oscillate like mad on that screen. Suppose it oscillates like this. And this could be 10,000 oscillations per centimeter. And your eye is able to look at it only 1 millimeter at a time. Then you're averaging over a region, and you only find the average of this graph. That looks like what you got without interference. So in order to see interference...
Right, but that's the argument is the stuff has to be further apart to create that higher, the longer lines. You have to have the longer lines that have more notches on the ruler. So it doesn't make any sense that light just passing through the air, for example, is being interfered with in any substantial way, because it's being transmitted, which is different than being scattered. And the fact is that it is scattered. Well, anyway, there's a lot of reasons not to buy this argument. And it still doesn't get to the point where the real math is doing just that geometry thing. It's just two straight lines, and it's either in phase or out of phase. You can't reconstruct the photon if it's out of phase. Certainly you need the little pieces to show up, but you have no hope if the little pieces are too close or too far away. You can't reconstruct the frequency then.
You need to make your apparatus probe the physics at a distance scale comparable to the wavelength. So that's the answer. We will see all the details, but it'll turn out that if you look at light using any equipment, maybe a hole in the wall, 2 holes in the wall, whatever, whose dimensions are much bigger than the wavelength, you will not see the wave theory of light. You'll be able to get away.
Okay, so he said it again. So he's saying that we have to have a slit that's 500 nanometers or smaller, which is just nonsense. You can see the pattern really well with something 3/4 of a millimeter. So that's just wrong. I mean, there's a technical point. I don't see much point in it. It's not a big point to make, but I'm just saying that doesn't make any sense at all. 500 nanometers is small. I mean, from our perspective. I mean, yes, atoms are even smaller, but I just mean it's still small.
For the geometric theory.
It's certainly not half a millimeter. 500 nanometers is not 1/2 of a millimeter. So, and like I said, I've done the experiment with something bigger than 1/2 a millimeter in terms of an opening.
But once you probe light at a length comparable to wavelength, all these funny things will happen. That's why people didn't realize all these things about light. For example,
So again, that just doesn't make any sense. So I don't know. It's just weird that they made that big a technical error. I mean, that's their math thing. Usually don't get math things wrong. So I don't know how you got this math wrong that 500 nanometers is half a millimeter. Because that's just bullshit.
the wavelength of light, typical light is 5,000 angstroms, or 500 nanometers. That is 500 times 10 to the minus 9, or 5 times 10 to the minus 7 meters.
Yeah. So
That means, if you forget the 5, there are 10 million oscillations of the wave within 1 meter. So if you
10
have an
million.
instrument that can pick up that kind of fine features, then you would see the wave nature.
10 million in a meter. So you know if it's a meter, then you break that down to what the hell's 10 centimeters? But anyway, and then you go to centimeters, and then you go to millimeters, and you'd still be left with more than, like I said, 500 nanometers is not half a millimeter. That's what he's just said here, basically.
But normally you won't. So it's only when people probe light with very, very tiny holes placed very close to each other, they saw it. Second important thing to remember.
All right, so I mean, it just proves that, again, just demonstrates that he really he hasn't really thought about this experiment much, right? He just read in a book when he went to college, and so these are just notions in his head that aren't really, because he hasn't really played with it. And so by playing with it, you know that half a millimeter makes a really good pattern. So there's no argument here. It's just wrong to say you have to make the slit as big as a wavelength. You don't have to go that small.
But it's the following. Even if you made the holes very small, and if you shine white light on this, you will not see any of these patterns.
So that's exactly what Young did. So again, he says you won't see the patterns. Of course you will. You'll just end up having some of it messed up by the fact that the red and the green and the blue won't line up. They'll make their own pattern in at different places. But if you look for just the blue ones, you'll see the pattern. If you look just the red ones, you'll see the pattern. So it's not like it really doesn't, I mean, fucks it up a little, but doesn't fuck it up entirely.
Why is that? Can you have a guess? I'm going to tell you everything, but can you guess why? Yes? You have a guess? That's right. White light is made of many colors and many wavelengths. So each wavelength will form its own pattern, but the maximum and minimum of one guy won't coincide with that of the other. So this one wants a maximum.
Right. The thing to understand, though, is that they're not sent to these different locations like a prism does or something like that. So the real truth is, again, the truth of the matter is that a lot of light goes in and less than that original amount of light will come out. And when they're separated, like you have the red line here and you have the blue line here, and I'll make the blue ones hollow or something, is the fact is the blue went everywhere and the red went everywhere. And the only place you put a red back together is here. I mean a blue. And the only place you put, the only place the lines match up for the phase lines work is in these locations. And the locations are different because the wavelength is different. The notch on the ruler is different. And so that's why the phases, the places where they'll match, lines up differently. But the energy went across this whole area. It's just you're only seeing it, okay, where they match their phase again. Where they're out of phase, it's still there. The energy, the blue light is right next to this blue you're seeing. It's just that now the contributions, the pieces, aren't in the right alignment. Okay, so they're out of phase. So you can't see that photon because the frequency is broken. But that's the only reason why you can't see it. There's the same number of little bits. It's just you can't see them because they're not in the right order. This is probably enough. I mean, he gets into the whole math thing pretty soon, but we'll play a little more.
That'll want a minimum, you'll get washed out. So in order to see this effect, you need monochromatic light sent by a source which is sending it at a definite frequency and wavelength.
Nope.
These are all things you have to get right before you will see these effects. Okay. So now let's ask ourselves.
So again, Young, 1801. He used sunlight. 1801. So he used white light.
What is the nature of waves, or what is the nature of light that produces these funny effects? Light, as you know, obeys a wave equation. Let me call psi as whatever it is that's...
All right, so this is the part we'll just skip over. He's saying it obeys the wave equation, right? Well, he hasn't done the right pattern, so obviously it doesn't obey the wave equation because it's not two waves and it's not doing the wave equation thing. It's more complicated than that, the system. So you have to use another equation, which is where you get into Fresnel and Funtenheimer, or whatever his name was, kinds of diffraction, and that's all vector math. So anyway, so I think we're okay, and we can pick this up later, maybe in another video, but I don't know if it's really important. I mean, he does, this is just math for, and it's not the right math is the funny part. So he's just talking about the wave equation. He's not even talking about it in the circumstance of the two slit experiment. He's just talking about it in a general sense. So it's just a lot of general crap about the wave equation, which is not useful because it's all, it gets into this whole unreal mathematics, this unreal components and all this kind of crap, and not worth the trouble in my opinion. Anyway, so that's probably enough of a video and such. Sorry for people who are find me obnoxious. Again, I have one purpose here, and that is to defend my theory, but I like to defend it against good arguments. And when people say I contradicted myself, that pisses me off. And obviously, when somebody says I haven't, or implies I haven't accounted for some brilliant argument provided by the Yale professor, that also pisses me off. So make good arguments or expect my wrath. So that's what you're going to get. And again, the fact that so few of you people concede the obvious, which is, yes, they have an under-evidenced, under-detailed, under-specific, ambiguous, floaty and spacey kind of amorphous theory. Every one of these physical theories sucks in the fact that it provides nothing. There's no energy in their gravity theory. They're bent space bullshit. There's no evidence of any motivation electrons have or protons have to move. They don't explain why the planet Earth moves towards the sun. What motivates it? There's no motivation anywhere. There's no energy. There's no mechanism. The same is true for their quantum mechanics. They call it virtual photon. They call it a force carrier. Well, the force carrier that isn't a force. I mean, what's the fucking point of this crap? It's so ambiguous and nonsensical. And then I show their cornerstone of their quantum mechanics, the cornerstone of their silly wave, gluey ether theory, is an experiment they haven't analyzed with any detail at all. They haven't really thought about it. They haven't really played with it in any kind of way to see what they could tease out of it as truth. And it's glaring that they're just reading out of a frickin' really old Bible. Maxwell and Young. It's an old Bible. And it's not nearly good enough. So anyway. Yeah, that's enough of a commentary. So, till the next time and such. So forth and whatnot.